Hey y'all, so today we are going to discuss lesson 2-4, equations with no solution or infinitely many solutions. All right, so our learning targets today, we are going to identify equations that have no solution, and we're going to identify equations that have infinitely many solutions. No solution, infinitely many solutions. So when you solve an equation, you could get one solution is what we did yesterday. When you solve an equation, you get a variable equals a constant. Well, today I'm going to show you what happens when you don't get a pretty answer like a variable equals a constant. What does it mean? Okay, so question 1. Remember that a solution of equation with one variable is a value of the variable that makes the equation true, such as if you solve an equation gets x equals 1. Well, that means that where the value 1 is substituted in the equation, you get a true statement. Okay, so question 1 says the set of numbers 1/2, 3, 6, 17, 0, 11 contains possible solutions to the following equations. Determine which of these numbers are solutions to each of the following equations. So I turned this over and I snipped these into a Jamboard so that I can have more space to write. All right, let's get started here. So it's asking which of these values in this set is a solution? What would make this equation a true statement? Okay, so I've got 9. Actually, I'm going to write this in black because I'm going to just rewrite the original equation. I've got 9 times x plus 5 equals 4 times x plus 2 plus 5 times x. Okay, now I'm going to change my color to red, and you'll see why I did that in just a second. All right, so let's start with 1/2. 1/2. I'm going to substitute in 1/2 where all my x's were in that equation. Okay, now let's simplify and see if we get a true statement and if 1/2 is a solution. 9 times 1/2. Well, 1/2 of 9 is 4.5. I'm going to simplify that to a decimal. We could leave it as a fraction, but to make things simpler, I'm going to change it to a decimal. Plus 5 equals 4 times, what's 1/2 of 2? Well, 1/2 of 2 is 1. Plus 1/2 of 5 is 2.5. So now I've got 4.5 plus 5 is 9.5 equals, what's 4 times 1? Well, that's just 4. And 4 plus 2.5, that is 6.5. So is 9.5 equal to 6.5? No, that is a no solution. No solution. So 1/2 is not a solution. 1/2 is not a solution. So let's now go down here. Let me erase all of this. So 1/2 is not our solution. Let's erase 1/2 and let's substitute in 3. So let's go and use 3, our next number in our set. Substitute in 3 for x. Okay, when I simplify this, 9 times 3 is 27 plus 5 equals 4 times, what's 3 plus 2? 3 plus 2 is 5. Plus 5 times 3 is 15. 27 plus 5 is 32. 4 times 5 is 20 plus 15. All right, so now I get 32 equals 35. Is 32 35? No. So that's no solution. 32 does not equal 35. So 3 is out. Okay. 3 is a no solution. Three is a no solution. All right. Now, let's change our 3. Let's go over here and get our pen in red. All right, so 1/2 was no solution. 3 was no solution. Now we're at 6. Let's see if 6 is a solution. Let's substitute in 6 into our equation. Okay, so when we substitute 6 into our equation, we've got 9 times 6, which is 54, plus 5 equals 4 times 6 plus 2. 6 plus 2 is 8, plus 5 times 6, and 5 times 6 is 30. Okay, so now we've got 54 plus 5 is 59. 4 times 8 is 32. Now we've got 59 equals 62. Is that a solution? No, because 59 does not equal 62. So 6 is not a solution. Okay, so now let's erase 6. All right, let's go to 17. If I substitute in 17 for x into all of these values, okay, I've got 9 times 17. 9 times 17 is 153. Plus 5 equals 4 times 17 plus 2, which is 19, plus 5 times 17. 5 times 17 is 85. Okay, 153 plus 5 is 158. 19 times 4 is 76. So now we've got 158 equals 76 plus 85, which is 161. So no, that's not a solution either, because 158 does not equal 161. So 17 is not a solution. So let's erase 17 and put in our next value. All right, 0. 0 is always the easiest. If you can ever substitute in 0, do 0. 0 is easy. You'll see why. 9 times 0 is 0. 0 plus 5 is 5. So I'm left with 5 on the left side. 0 plus 2 is 2. So I'll write this down. 4 times 2. And then 5 times 0 is just 0. So 5 equals 8. Does 5 equal 8? No. So 0 is a no solution. Are we going to have a solution for A? All the ones that we substituted so far have come out to false statements. All right, last one. Let's see if we have a solution. 11. Let's put in 11. Okay, when we substitute in 11, 9 times 11 is 99. Plus 5 equals 4 times 11 plus 2, which is 13. Plus 5 times 11, which is 55. Now we've got 99 plus 5, which is 104. 4 times 13, which is 52. Oops, that's a plus sign. Now we've got 104 equals 52 plus 55, which is 107. So no solution again. So all these values were not solutions. So if you go back to your book on part A, none of the numbers is a solution, and that is why. Whoops, I did not mean to move the screen over. None of the solutions is, or none of those values is a solution. None of the numbers is a solution. And the reason is because of what I just showed you on this Jamboard here, is that when I substitute in all of these values into this equation for x, I get no solution. None of them create a true statement. In a true statement, if you don't know what it looks like, say this ended up being 107 equals 107. that would be a true statement. If 107 equals 107, because that is true, that would be a solution. Okay, so let's go to B. Let's go to B. So B is a little bit smaller. Okay, so let me rewrite this. 7 times x minus 10 equals 3 times x plus 14. All right, so we're going to do those same steps. 7 times 1/2, 3 times 1/2. Substitute in the value of 1/2 where x is. 7 times 1/2 is 3.5 minus 10 equals 3 times 1/2 is 1.5 plus 14. Okay, so 3.5 minus 10 ends up giving you negative 6.5. And 1.5 plus 14 is 15.5. So again, that's no solution. Negative 6.5 does not equal 15.5. So 1/2 is not a solution. Okay, so let's erase all these values here. All right, now let's substitute in 3. 7 times 3 is 21. 3 times 3 is 9. 21 minus 10 would give you 11. 9 plus 14 would give you 23. That's a 3. So that is also a no solution. 3 is not a solution. Okay, now let's go over here. Erase the 3. Replace it with 6. If x is 6, what happens? 7 times 6 is 42 minus 10 equals 18 plus 14. So I've got 32 equals 18 plus 14 is 32. 32 equals 32. Yes, finally, we found a solution. So 6 is a solution. Okay, so let's erase 6 and see if any of these other values are a solution. All right, now we're at 17. Seven times 17 is 119 minus 10 equals 17 times 3 is 51. 119 minus 10 is 109. 51 plus 14 will be 65. So that is also a no solution. So 17 is out. Now let's go in and substitute in 0. 7 times 0 is 0. 0 minus 10 is negative 10. 3 times 0 is 0. 0 plus 14 is 14. So no, 0 is also not a solution. All right, now we've got 11. Last one for part B. 77 minus 10 equals 33 plus 14. 77 minus 10 is 67. 33 plus 14 is 47. So no. So the only number in this set that is a solution is 6. So going back to your book, there we go. 6. All right, so let's go to part C. I'm going to do the same thing. I'm going to rewrite 3 times x minus 12 equals 3 times x plus 1 minus 15. All right, now let's look at these values. Let me change my color to red. 3 times 1/2, 1/2 plus 1. All right, so 3 times 1/2 is 1.5 minus 12 equals 3 times 1/2 plus 1, which is 1 and 1/2. Again, I'm changing to decimals just to make my life easier, and you can most certainly do that. All right, so 1.5 minus 12 ends up being negative 10.5. 3 times 1.5 is 4.5 minus the 15. So now we end up with negative 10.5 on the left, and 4.5 minus 15 is negative 10.5. So 10.5 equals 10.5? Yes, that is true. So 1/2 is a solution. All right, let's erase all this and substitute in 3. All right, when I substitute in 3, let's see what happens. I've got 9 minus 12 equals 3 times 4 minus 15. 9 minus 12, you're going to end up with a negative 3. And 3 times 4 is 12 minus 15. Negative 3 equals 12 minus 15 ends up giving you negative 3. So I've got negative 3 minus negative 3 equals negative 3, which is a true statement. So 3 makes that equation true. Okay, let's go to the next one, 6. Got 18 minus 12 equals 3 times 7 minus 15. 18 minus 12 is 6. And then 3 times 7 is 21. And then 6 equals 21 minus 15 is also 6. So 6 equals 6. Therefore, 6 is a solution. All right, now let's go to 17. Substitute 17 for the value of x. I've got 3 times 17, which is 51, minus 12, equals 3 times 17 plus 1 is 18, minus 15. 51 minus 12 gives you 39. 3 times 18 gives you 54. And 54 minus 15 would end up giving you 39. So 39 equals 39, which is a true statement. So 17 is a solution. Okay, now let's go to the next value, 0. If I substitute in 0, I've got 0 minus 12, which is negative 12. And I've got 3 times 0 plus 1, which is 3 times 1. So negative 12 equals 4 minus 15, which is negative 12 equals negative 12. So 0 is also a solution. Okay, so now let's go to the last one, 11. When I substitute in 11, what happens? When I substitute in 11, I've got 33 minus 12 equals 3 times 12 minus 15. 33 minus 12 leaves you with 21. 3 times 12 is 36. And when you subtract 15 from 36, that leaves you with 21. So 21 equals 21. So 11 is also a solution. So if all of those values in that set are solutions, that means that all the numbers are solutions, which is what you see there in the answer book. All right. Math tip. An equation is true when both sides of the equation have the same value. Otherwise, the equation is false. So 2 plus 3 equals 5 is a true mathematical statement because 2 plus 3 has the same value as 5. 2 plus 3 equals 6 is a false mathematical statement because 2 plus 3 does not have the same value as 6. That would be 5. 5 does not equal 6, so that's a false statement. An equation has no solution if there is no value of the variable that will create a true mathematical statement. An equation has infinitely many solutions if there's an unlimited number of values of the variable that will create a true mathematical statement. All right, so number 2, Laura, Nina, and Leo solve the following 3 equations as shown. Identify each of the equations as having one solution, no solution, or infinitely many solutions, and justify your response. Okay, so if you look at Laura solved this equation. If you want to go back and look at the work on how Laura got her answer, that will give you extra practice. But if you look at Laura's equation there, she solves it and gets x equals negative 11 over 15. I have a constant set equal to a variable. That means that this equation has 1. A constant set equal to a variable, or it could be written as x equals negative 11 over 15. When you have a variable and a constant, there is one solution. Okay, well, Nina got 2 equal 2. 2 equal 2. So that goes back to the problems in number 1 that we were doing together in part A, B, and C. If I got the same value set equal to the same value, that was a solution. Well, in this case, when I solve an equation and I get the same value on both sides, that is infinitely many. That is infinite. That is a T. Infinite many. Now, like we did in part 1 again, 6 equals 17. If I solve an equation and I end up getting 6 equals 17, 2 totally different constants on each side of the equal sign with no variable, that means this is no solution. There is no value of x in that solution or in that equation that would make that a true statement. It has no solution. So when you solve equations, you're going to get your answer to look like one of these 3. A constant set equal to a variable, which is one solution. That's the only value of that variable x that would make this equation a true statement. You would have infinitely many, which means you have the same on both sides. It could be 2 equal 2. It could be 5 equals 5. It could even be something like x equals x, okay? Which by then you should simplify even further, but you could stop there, okay? It could also look like something like this. You could also have something, and you can stop here. You could even stop when you're solving an equation and you identify 2x equals 2x. You have the same on both sides, so it's infinitely many. You can stop there, okay? You don't have to complete the equations all the way through. You can also see something. Let me erase this. Infinitely many solutions can also look like this. 2x plus 1 equals 2x plus 1. You have the same on both sides. So anytime you have A equals A, anything the same on both sides, it's infinitely many. And then if you have something like Leo, where it's A equals B, 2 totally different things with no variables, it's no solution. It could be any constant set equal to any constant. Okay? All right, now we're going to page 26 in your book. I want you to pause the video and complete numbers 3, 4, and 5, and you're going to submit that as part of your classroom assignment. Some equations are true for all values of the variable. This type of equation has all real numbers as solutions. This means the equation has infinitely many solutions. Other equations are false for all values of the variable. This type of equation has no solutions. So which of the following equations has no solutions and which has real numbers as solutions? And explain your reasoning. So I've got 3x plus 5 equals 3x. There's no solution. A number cannot be equal to itself plus 5. So you can just look at this equation here, 3x plus 5 equals 3x, and identify that if I have 3x and I have 3x, well, that's the same on both sides of the equal sign, right? 3x and 3x. But then on the left side over here, you see a plus 5. Well, I can never add 5 to the same value 3x and end up getting the same. If you can't identify that, you can come up over here to the side. 3x plus 5 equals 3x and solve it. If you cannot identify that this is no solution, that's fine. Do the mathematics for it. So I want to isolate the term of the variable. Well, in order to do that, I'm going to subtract 3x from both sides. So 3x minus 3x cancels, and that leaves me with 5 equals 3x minus 3x. That also cancels, and that'll leave me with 0. 5 equals 0. Well, 5 equals 0 is no solution because that's a constant set equal to a constant. So part A is your no solution. Part A is your no solution. Part B, if you look at part B, like I just explained in Nina's explanation on page 25, where I said if you had the same on both sides, it's all real numbers, it's infinitely many. Well, look here, 4r minus 2 is equal to 4r minus 2. It's the same expression on both sides of that equal sign. If I have the same expression on both sides of the equal sign, I can just stop there. And I can say, hey, I've got the same on both sides of the equal sign. That means that this is infinitely many. It doesn't matter what value I substitute in for r. I'm always going to get a true mathematical statement with the same constant on both sides. If you can't identify that, come over here to the side. 4r minus 2 equals 4r minus 2. If you continued on here, you would say, okay, I need to isolate my term with my variable. So I'm going to move 4r to both sides. I'm going to subtract 4 from both sides. I'm sorry, to move it. 4r minus 4r is 0. 4r minus 4r is, 0. They both eliminate. And that leaves me with negative 2 equals negative 2. You're left with a constant equals a constant with the same constant on both sides. Therefore, B is infinitely many solutions. It's all real numbers, infinitely many. Okay, number 7. A student claims that the equation 2x plus 6 equals 4x plus 4 has no solutions because when you substitute in 0 for x, the left side has a value of 6 and the right side has a value of 4. Is the student's reasoning correct? And explain. No, that is not true because just because x equals 0 is not a solution does not mean that the equation has no solutions. There's infinitely other number of values other than 0. So when you solve the equation for x, you get that x equals 1 is a solution. So the equation does have a solution, which is x equals 1. Oops, I don't have my pen on. X equals 1 is a solution. So I'm going to come over here and show you that. 2x plus 6 equals 4x plus 4. Okay, I want to isolate the term of the variable, so I'm going to subtract 2x from both sides. 2x minus 2x eliminates and leaves me with 6 equals 4x minus 2x is 2x plus 4. Now I want to isolate the term with the variable by subtracting 4 from both sides. And I get 6 minus 4 is 2 equals 2x. 4 minus 4 cancels. Let me scroll down here a little bit. Now I need to isolate the variable. In order to isolate the variable, I'm going to divide both sides by 2. Oops, I didn't mean to do that. 2 over 2 doesn't eliminate. What are you doing, Miss DeWitt? 2 divided by 2. All right, so 2 over 2 over here eliminates to 1x. And 2 over 2 here simplifies to 1. So x equals 1. That is not a z. That is an equal sign. X equals 1. X equals 1. Okay? So just because the student said, hey, this equation has no solutions because 0 isn't a solution, well, that doesn't matter because if I solve this equation, I get that x equals 1. If I substitute in the value of 1 into this equation here, I get a true statement. 2 times 1 is 2, plus 6 is 8. 4 times 1 is 4, plus 4 is 8. So you end up getting 8 equals 8, which is a true statement. Okay, explain why the equation x plus 3 equals x plus 2 has no solution. This requires no mathematics. It's just saying, why does this have no solution? Well, if you needed to go through and you need to do the mathematics and subtract x from both sides, you get 3 equals 2. So your answers can vary. You can use mathematics to explain it, but the way the book wants you to recognize is that subtracting x from both sides of the equation results in the false statement 3 equals 2. Okay, so if I subtract x from both sides and I isolate the term to one side of my equation side, I get 3 equals 2. You can also use the explanation, well, I have x and I have x on both sides. If I add 3 to some number on the left side and I add 2 to that same number on the right side, my values will never be equal. My equation will never be a true statement because my total value on the left side will be 1 more than my total value on the right side. All right, number 9, for what value of a does the equation 3x plus 5 equals ax plus 5 have infinitely many solutions? Remember, to have an infinite many solutions, my equation has to have the same expression on both sides of the equal sign. So I've got 3x plus 5 on the left. So what do I need to have a equal to have the same expression on the right? Well, a needs to be 3. 3x plus 5 equals, if I change a to 3, I'll have 3x plus 5. And both expressions are the same on the left side of the equal as the right, which means that has infinitely many solutions. Okay, number 10, consider the equation nx minus 4 equals 6. What are the solutions if the value of n is 0? Well, if the value of n is 0, let's go over here, number 10. Nx minus 4 equals 6. If I change the value of n to 0, that would be 0x. That would be 0x, which means negative 4 equals 6. So now my expression simplifies to negative 4 equals 6. Well, if I do that, there's no solution. When you substitute 0 for n in the equation and simplify, you get negative 4 equals 6, which is false. Okay. So what if the value of n is 2? What is the solution of the equation and how do you know? Well, if I substitute in 2 for n, I've got 2x minus 4 equals 6. I substituted in the value of 2 for n, and I've got 2x minus 4 equals 6. Well, if I solve this equation, I need to isolate the term with the variable by adding 4 to both sides, and I get 2x equals 10. Okay, that is a 2x equals 10. Now I need to isolate the term x by dividing 2 from both sides. When I do that, let's see if I can scroll down here. The internet at the school is getting laggy. Y'all bear with me. I'm almost done. When I divide 2 on both sides, I get x equals 5. 10 divided by 2 is 5. There we go. We finished. Okay. So when you substitute 2 for n, the equation is 2x minus 4 equals 6. Solving that shows that x equals 5, which is one solution. Now, your page 27 in your book, if this will let me scroll down. Page 27, there we go. All right. Almost done. Page 27 in your book has a check your understanding, numbers 11 through 14. I want you to complete numbers 11 through 14 right here, 11 through 14, check your understanding. Complete that as the second part of your classwork and turn that in the Google form for classwork. And then lesson 2 for practice on page 27 that you see there, numbers 15 through 21 is your homework. And I want you to complete that and turn that in for a homework grade in the Google form. Okay, thank y'all and sorry for the internet problems.